In the previous video, we developed our first Hello World application on different platforms. However, real applications are more complex than a Hello World application, therefore we need a set of development tools. In this section, we will introduce some useful development tools and install. You first need to choose a code editor to develop PhoneGap applications, for example TextMate, Sublime Text, WebStorm, Eclipse, and so on. It is better to choose an editor that can work seamlessly with HTML, CSS, and JavaScript, since most of our development will deal with these languages. You also need to choose a WebKit-based browser, since our application will be running inside of a WebKit web view. Besides, WebKit-based browsers normally provide an inspector, which we will use to debug our application locally. For debugging applications running in mobile devices remotely from our computer, we need Winery. Finally, we need a source code version control tool, which will help us manage our source code so that we can revert errors, share our code, and so on. In this course, we are going to use Git, which is a very popular version control tool. You can choose any WebKit-based web browser, such as Safari or Chrome. We are going to use Chrome. Download Chrome from this URL and install it by following each step shown here. Winery is a remote debugger for web pages based on Node.js. You can install and then run Winery locally, or we could simply use a Winery instance hosted by PhoneGap. Visit debug.phonegap.com and follow the steps there. Node.js needs to be installed if you want to run Winery locally. We've installed Node.js previously. After Node.js has been installed, you can install Winery through npm. Use -G to install it globally so that Winery can be executed from the command line. After it has been installed, we can run it from the browser. Use the browser to open this address. Then you can follow the instructions displayed. We use Git as our version control tool. If you are using a Mac, it comes with your macOS build. Otherwise, you need to go to this URL and install Git. It has everything you need. In this section, we have primarily set up our development environment. In the next section, we will talk about how to debug code. In this section, we will dig into how to debug our app through WebKit Inspector. WebKit Inspector allows developers to view the live DOM hierarchy, edit CSS on pages, and add breakpoints in the JavaScript. To start a web inspector, we first need to open a WebKit-based browser. Here, we will open Google Chrome. Once done, you can go to Menu, Tools, Developer Tools to open the WebKit Inspector. The Elements panel provides the HTML hierarchy and live CSS related to each of those HTML elements. The Resources panel contains the hierarchy of all of the resources, like HTML, images, videos, scripts, local storage, and so on. The Network panel lists what web requests your apps have performed. The Sources panel, which is a script panel, is where we debug our JavaScript code. Timeline panel shows the details of what's happening by time when your app is running. The Profiles and Audit panels can be used to test the app's performance. And the Console panel allows you to run JavaScript on the fly. The Winery user interface is similar to that of WebKit Inspector. Start up the Winery server or use the PhoneGap Winery host. Copy the script tag and embed it into index.html, which is the file we will debug into. Then load the page in the browser. The browser will connect to the Winery server automatically when the page is loaded. We can now debug the web application using Winery. The Winery layout is similar to WebKit Inspector. We will talk about how to debug the app later. We use our Hello World application as an example. Open index.html using Google Chrome. For reasons of cross-domain access security, it is better to set up a web server to host those web files. and we will come to that soon. Another alternative is to use the Cordova serve command introduced before. Open the inspector. In WebKit Inspector, we can override a series of browser settings like user agent, DOM dimensions, and so on. We change the DOM dimensions here to make it more like a mobile device's screen dimensions. We will now go to the Elements panel, where we can view the live DOM hierarchy, edit HTML tags, and change the CSS properties. To edit the content of an element, simply double-click on the content and change the text to whatever you want. Double-click on the element's attribute to edit it. We add a style attribute to the element here. You can also edit an entire element's HTML code, add extra HTML code, or delete an entire element. Your changes will be reflected only in the browser. If you refresh the page, the changes will be gone. The CSS of the elements are listed in the panel to the right. You can easily find out from where these CSS properties are coming. Besides, the inspector also lists the result of the computed style, which is the actual current CSS value for an element. To add styles to an element, double-click on here and type in the CSS name and value. As another example, let's bring the Click Me button to the center of the page and round the corners. To debug the JavaScript code, open the Source panel. You can find all the loaded JavaScript files here. Let's open the index.html file, where we have put our JavaScript code. The embedded JavaScript code is also debuggable. Click on the line number to add a breakpoint. Click on it again to remove the breakpoint. Breakpoints pause the JavaScript from running when it reaches that line. When it is paused, we can check out the value of the variables or run the JavaScript code in the console. There is a toolbar on the top right, with which we can control the debug process. This button can be used to toggle between whether the inspector automatically pauses JavaScript from running when an error occurs, or it does not. In this section, we talked about debugging PhoneGap applications. You should be able to debug your application with either a computer or a mobile device. In the next section, we will introduce how to use Git to manage our source code. In the previous section, we've introduced how to debug our applications. In this section, we will talk about Git, which plays a very important role in application development. Git is a distributed version control system. It manages the source code for our application. To start with Git, we will create a new folder which will act as our workspace. We use the git init command to initialize this folder as a Git repository. It will track changes in that folder after initialization. Before committing any code, don't forget to set up your name and email. This information will be used to track the author of each commit. For the first commit, we normally create a README file and add something to introduce the project. The git status command is always used to check if we have made any changes in the Git repository. We can see that the README file is untracked, and we need to add it to a track. Use the git add command to add all files in the current repo to the track. Now, running the git status command will show you some uncommitted changes in the repository. We need to use the git commit command to commit those changes. Using the git status command now should output that there is nothing to commit. The git branch command is used in multi-developer and parallel development. By default, Git will automatically create a master branch after the first commit. To create a new branch, use the git branch command with a new branch name. The new branch is created. The branch name with an asterisk in front is the current branch. To switch the current branch to our newly created branch, we need to use the git checkout command. Here we go. The current branch is named New Branch. The new branch should contain the same content and commit history as the old one when it is created. The changes made in this branch will not affect the old branch. Now we commit some changes to the new branch and check out the old branch. As we can see, it's not affected at all. We can use the git checkout command with -b to create a new branch and check it out. Since it is created based on the master branch, it doesn't reflect the changes we have made in the new branch. We can use the git merge command to merge commits in the other branch into the current branch. Most of the time, the git merge command works fine. However, when two branches have changed the same file in the same line, the git merge command will raise a conflict error while merging. Let's have a look at an example. Say we are in another branch and change the file's name to new file in new branch. We add something at the first line. We then commit the change to the current branch. Check out the new branch. Edit the file. We put something different in this file. Commit the change in this branch. Now, if we merge another branch into the current branch, it will output an error saying there is a conflict. We need to solve the conflict manually by editing the conflicted files and then committing those changes. The git status command will help us find out which files are not merged. Now we commit the changes to solve the conflict. Reverting changes is one of the most powerful features of Git. Here are the most commonly used reverting commands. We will introduce them one by one. The git reset command allows you to reset a specific file to a history state, or set the current branch head to a history commit with or without replacing the current working tree. As an example, let's create a file and add some contents. Commit the change. The git log command lists the past commits. Use it to have a look at the commits. We make some more changes to that file and commit them. Then we want to reset the file to the old version, when we made the first change after creating the file. The commit should be named ch1 test file. Copy the commit hash. This will copy the content of test file from the ch1 test file commit to our index tree. It will not affect the current working tree. That is why we see an M flag in front of test file. You see, the content of the file in the current working tree has not changed. We can use the git checkout command to check out the content of that file from the index tree to the working tree. The file content has been changed. Now, running the git status command will say there are differences between the index tree and the head branch. Finally, we need to create a new commit for this change. The reverting has been completed. The git reset command can also set the current branch head to a past commit. The option hard will reset not only the head branch, but also the index and working tree. You need to be careful since any tracked changes after the reset past commit will be discarded. As an example, we reset to our first commit. You will note that all the changes are gone permanently. Through the git log command, any commits after the first commit are discarded. The git revert command reverts changes made in one commit and generates a new commit based on those changes. It requires your working tree to be clean. For example, we create a new file in the current branch and modify the file in several commits. Here we have them in the commit log. Now we want to revert the changes made in the last commit. Unlike the git reset command, which directly sets the current head branch to the last commit, the git revert command will reverse the changes of that commit and create a new commit for the changes. And don't forget your revert commit messages. If we use the git log command to check the commit history, we will see the commit it created. Let's check the content of the file. Note that the change made to this file in the last commit was reverted. The git revert command sometimes causes conflict if the reverse changes of some files in that commit conflict with the changes of the commits afterwards. Just as with the git merge command, we need to solve these conflicts manually. The last command we are going to introduce is git clean. It simply removes untracked files from the working tree. Be careful, those untracked files will be removed permanently. We create a new file for demonstration purposes. Use the git status command to show all untracked files. Now clean them. They are all gone. Git has many other useful commands, and we will cover them in upcoming videos. In this section, we simply introduced how to use Git to manage our source code. In this chapter, we have prepared tools we will need before development. In the next chapter, we will dive into cutting-edge web technology, HTML5 and CSS3, and also explore how to use the PhoneGap API.